start with a very basic problem to quickly review how calculus can be used to identify maximum and minimum values. Then we'll move into our rectangle example. Imagine we want to build a rectangular fence with a fixed amount of fencing material, meaning the perimeter is fixed at some value p. The question is, among all possible rectangles with that perimeter, which one gives the largest area? To solve problems like this, the general method is always the same. First, we set up an equation for the quantity we want to maximize or minimize. Next, we take the derivative and solve for where it equals 0 to locate possible maximum or minimum points. Then, we check the second derivative at that point. If the second derivative is negative, as shown in the graph, the curve opens downward and the point is a maximum. If the second derivative is positive, the curve opens upward and the point is a minimum. This systematic process allows us to confirm whether we have found a maximum or a minimum. Now, let's apply this to our rectangle. Let one side of the rectangle be x. Then the other side must be p over 2 minus x, because the sum of the two sides must equal half the perimeter. The area is base times height, so the area function is a of x equals x times the other side, which is p over 2 minus x. Multiplying out, this becomes p over 2 times x minus x squared. To find the maximum area, we take the derivative. The derivative of a with respect to x is p over 2 minus 2x. We set this equal to 0 to locate critical points. Solving, we get x equals p over 4. If x equals p over 4, then the other side, y, is also p over 4. That means the rectangle becomes a square. To confirm this is a maximum, we check the second derivative. The second derivative is -2, which is less than 0, so the graph of the area function opens downward. That tells us the point we found is indeed a maximum. Therefore, when the perimeter is fixed, the rectangle with the greatest area is a square.